Alright everyone, welcome to Learning Math with Eric, and in this lesson we're going to be talking about how to solve one-step equations. Now, one-step equations are going to be very simple equations. It's going to be a beginning to solving much more complicated equations. You have to start here. Now, for one-step equations, your goal is to isolate the variable, which means getting it by itself on one side of the equation. So we're going to be talking about all that in the next, in some examples a little bit later on this video. But for now, we need to understand what an equation is and why we need to balance an equation. So in these next couple of examples, we're just going to be talking about what an equation is and the importance of balancing it. So let's get started. So let's head on over to my first example here. So this is what I wrote out right here. Now let's read it. The first thing you need to know about solving equations is that whatever you do to one side of the equation, you must also do to the other side of the equation. Now what does that actually mean? Well, let's take a look. So here we have the equation 8 equals 8. If we add 3 to the left side of the equation, but not the right, we get 11 equals 8, which is a false statement. So I just put a line through it because 11 does not equal 8. It's impossible. If, however, we add 3 to the left and the right side, we get 11 equals 11. And 11 equals 11 is a true statement, so our equation is balanced. So that's all you really have to remember for now. Whatever you do to one side of the equation, you have to do to the other. And think of an equation like a balance scale, and you'll actually see an example of a balance scale in the next example. But an equation is just like a balance scale. If you add something to one side, you have to add it to the other, because you want to keep both sides equal. Now let's take a look actually at our next example here, which includes the balance scale, I believe. Yep, so this is the actual definition of an equation. So an equation is just a mathematical sentence that contains an equal sign. So here we have x equals 8. Now usually when you're asked to solve an equation, you're never gonna, well, this equation is actually solved. When you're solving equations, it's not going to be solved for you. So depending on how complex the equation is, it's going to take more work for a more complex equation, and it's going to take less work for a less complex equation. So this equation right here, x equals 8, it's already solved for. And I actually provided a balance scale so you can actually see what x equals 8 means. So I just put a picture of a balance scale here, and then I actually put a bag with an unknown number of blocks, and I put that on the left side of the scale, and then I put 8 blocks, 1, 2, 3, 4, 5, 6, 7, 8. I put 8 blocks on the right side of the scale. So we have the equation x equals 8. And what that means is that there must be 8 blocks on the left side, or in the bag on the left, in order for it to be equal to the 8 blocks on the right side. Now you may be saying, or you may not be saying that the bag, it does add some extra weight in the scale. So it may be a little bit heavier. We're not going to worry about that. We're just going to pretend the bag doesn't weigh anything. We're just going to say that we're just going to say that the left side is equal to the right side. So if we know that some number of blocks equals 8 blocks, then we know that x equals 8, because there must be 8 blocks on the left side in order for there to be 8 blocks on the right side. Because if there wasn't, then the equation, or the balance scale in this case, would not be balanced. Alright, in this problem right here, we have x plus 2 equals 6. So this is our first example. Now you may be saying to yourself right away, well, x is equal to 4, because 4 plus 2 equals 6. Well, you're absolutely right if you said that. 4 plus 2 does equal 6, so x is equal to 4. However, when you're faced with a longer equation involving multiple steps, it's going to be very difficult to get the answer that quickly. So what we want to do is we want to figure out the steps how we would solve these easy equations, so when we get to the harder equations, although there may be different steps we might take, we know how to solve the equation. So that's just the purpose of doing these equations right now. Although they may be easy to do in your head, when we get to harder equations, which we will be doing later in later videos, you're going to see then it's going to be much harder to solve the equation. So let's talk about how we would solve this. So we see that x plus 2 equals 6. So when you're asked to solve for x in an equation, what you're really being asked to do is to get x by itself on one side of the equation, or whatever variable you're using. It could be a or m or q, whatever variable you're using. In this case, it's x. So how do we get x by itself? Well, since 2 is being added to x, we can subtract 2 from the left side of the equation. And remember that if we subtract 2 from the left side of the equation, we must also subtract 2 from the right side of the equation to keep our equation balanced. Now on the left side, the plus 2 and minus 2 cancel each other out, and we're simply going to be left with x. And on the right side of the equation, 6 minus 2 simplifies to 4. So we have x equals 4, which is going to be the solution to this equation. Now, the nice thing about solving equations is that you can always check your answer to make sure it's right. Now, we can do that by plugging the value of our variable, which in this case is 4, back in for x in the original equation. And if we do that, I'm going to just put this below. I'll just put check. Now on these easier equations, it is a good idea to check your answer. On harder equations you'll be faced with, it takes a little bit longer to check your equations, but let's just get into the habit of doing this now. So check, we're just going to plug, let me just grab a different color. How about we do this color right here. So we're just going to plug a 4 back in for x, so we're going to get 4 plus 2 equals 6. Now I use parentheses around the 4. I'll be talking about this in a later video, but it's a good idea to get into the habit of using parentheses when substituting numbers in for variables. So we have 4 plus 2, which is 6, so we have 6 equals 6. And since 6 equals 6 is a true statement, we know our answer is correct. Alright, in this equation right here, we have x minus 3 equals negative 8. Now this equation involves positives and negatives, and I have not done a video on positives and negatives yet, but if you're watching this video, this is going to be a pre-algebra, algebra 1 video. You should know how to be able to deal with positives and negatives already. I will be doing a video on my channel quite soon, I believe, on how to add and subtract positives and negatives, but if you're solving one-step equations, you should already know how to do this. So we're just going to add 3 to both sides of the equation first, because remember, we are isolating our x term. So how do we get it by itself? We're just going to add 3 to both sides. Especially with these one-step equations, the last one and this one are quite similar, except that we're just going to be adding instead of subtracting. So on the left side, we're just going to get x, and on the right side, negative 8 plus 3 simplifies to, actually I'm just going to cancel this out just so you can see, negative 3 plus 3 cancels out. And we're going to get x equals negative 8 plus 3 simplifies to negative 5. So x equals negative 5 is going to be the solution to this equation. And remember, in the previous example, I told you you can check your solution by just plugging the value of your variable, back in for your variable in your original equation. So if we plug a negative 5 back in for x, we're just going to get negative 5 minus 3 equals negative 8, and negative 5 plus negative 3 can be thought of as negative 5 plus a negative, or negative 5 minus 3 can be thought of as negative 5 plus a negative 3, and negative 5 plus negative 3 is going to be negative 8. So we have negative 8 equals negative 8, and since negative 8 equals negative 8 is a true statement, our answer checks, and we know that it's correct. So in order to be able to solve equations effectively in this lesson, you're going to have to be able to deal with positives and negatives. Alright, this is our next example right here. So how do we get negative 7 by itself? Well, this is a little bit different than the previous two examples. Now, in this, you should also be able to, you should be familiar with this. In algebra, when you have a variable next to a number, it's automatically assumed that it's multiplication. So really, this just means the same thing as, I'm just going to write it out here, negative 7 times x equals 35. Just negative 7x is just a shorter way of writing that. So I'm just going to erase this. There we go. Yeah, so when you just have a variable next to a number, it just means multiplication. So if negative 7 is being multiplied by x, think about this. How would you get x by itself? Now pause the video for a moment to see if you can come up with an answer. Resume the video when you think you know it. Alright, so to get negative 7 by itself, we're just going to divide both sides. Oh, I'm just going to use a different color here. I'm going to use my blue color. We're just going to divide both sides by negative 7. Now that's going to isolate our variable. because negative 7x divided by negative 7, a negative divided by a negative is a positive, so we're just going to get a positive x. So we're going to get x, and I'm going to actually cancel those out just so you can see. And one thing I didn't actually mention is you can write 1x if you want to. I mean, I'm just going to change that. Yeah, you can write 1x if you want to. It doesn't really matter. Usually when you get into higher level math, you don't really, it's not like the best thing to write a 1x, although it takes longer. So just x means the same thing as 1x. And 35 divided by negative 7 simplifies to negative 5. A positive divided by a negative is a negative. So make sure you're also familiar with your multiplication rules, actually, and division rules for solving equations. So we have x equals negative 5, which is the solution to our equation. Like we've done in the past two examples, we're just going to check it. Now, since x equals negative 5, we just plug a negative 5 back in for x in our original equation, and we have negative 7 times negative 5 equals, negative 7 times negative 5 equals 35, sorry about that. And a negative times a negative is always a positive, so we're going to have positive 35 equals 35. And since 35 equals 35 is a true statement, we know that our answer is going to be correct. Alright guys, this is going to be our last example here. This is going to involve division. Now, how do you undo division? Well, just pause the audio for just a quick moment, see if you can come up with that answer. Well, the inverse of division is multiplication. So if x is being divided by negative 2, we can multiply both sides of the equation by negative 2. So if we multiply both sides of our equation by negative 2, the negative 2's on the left side of the equation cancel out, and we're simply left with x. And I'll show you that, they just cancel out. And on the right side of the equation, negative 3 times negative 2 simplifies to positive 6. You don't have to write the positive symbol, I just wrote it because just so you know that a negative times a negative is going to be a positive 6. You don't have to write the positive sign in front of it, but I just wrote it. Now, I'm not going to check my solution for this problem because I want you guys to check your solution, see if that gives you a true statement, which it should give you a true statement. You can just do your work on a piece of paper, electronically, whatever, and then you should get positive 6 as your result. Now, I just want to go over this first step here because this is an area where students sometimes get confused on what to do. Now, the reason why I multiplied both sides by negative 2 is because if something's being divided by negative 2, just think of an addition equation. Let's take a look at a quick example down here. Something that we've, a similar problem to like our first example. X plus 2 equals 8. We're just subtracting, not subtracting 6. We're just subtracting 2 from both sides to isolate x. And that's kind of like the same thing here. We're not subtracting negative 2, but the inverse of division is multiplication. Just like the inverse of addition right here is going to be subtraction. So that's why we're going to end up multiplying both sides by negative 2. We're just doing the inverse of what is happening to the x here. And in this case, since it's being divided by negative 2, we're just going to end up multiplying both sides by negative 2 to get x equals positive 6.